Hello everyone, and welcome to part 2 of our video on derivatives of sine and cosine. So we just want to look through 2 more examples, and then we'll look at one example of a higher order derivative. So here we have an example where we've got cosine x times sine of 2x. So again, it's a product rule question. We're going to need to take the derivative of cosine x and multiply it by sine 2x as is, plus the derivative of sine 2x times cosine x as is. So we're going to take the derivative of cosine x, which is negative sine x times sine 2x. And here, the derivative of sine 2x is cos of 2x times 2, because it's a chain rule, times cosine x. And if I tidy that up a little bit, this is where your book stops. But you'll notice that I continued going. This is okay, but if we're going to solve a problem with this, we could try to use some of our trig identities, our double angle identities, to help us expand and simplify a little bit. So you'll just notice that sine of 2x can be replaced with 2 sine x cosine x, and cos of 2x can be replaced with 1 minus 2 sine squared x. Both of those formulas are given on the IB formula sheet. And then I can expand here and here, collect like terms, and factor out a common factor. So this form is easier if we're going to do something with that derivative after we're done taking it. And then last, I want to show you that we can also have our exponential functions mixed in with our trig functions, just like we have polynomial functions mixed in. The rules are still the same. This is still a function times another function. So we're going to use product rule again. The derivative of e to the 2x times tan x as is, plus the derivative of tan x times e to the 2x as is. Remember, the derivative of e to the 2x is e to the 2x times 2 times the original tan x. The derivative of tan x is 1 over cos squared x. Now, we saw that in the last video, and that is a rule for tan x that I will show you in our next video. Okay, and then last, times e to the 2x, and we collect our like terms and simplify. Okay. Then we have an example of a second order derivative. You study this independently on your own, but here's an example of a second derivative and a third derivative using a trig function. So for this function, 2/3 sine 3x, we take the derivative, we factor out that 2/3, take the derivative of sine of 3x, which is cos of 3x times 3, and simplify. If I take the derivative of the derivative to get the second derivative, I factor out the 2, take the derivative of cos 3x. There's a little prime there, it's hard to see. So the derivative of cos 3x is negative sine 3x times 3, and combining together, I get negative 6 sine 3x. Finally, if I take the third derivative, that's what this bracket notation indicates here, of negative 6 sine 3x, I factor out the negative 6, take the derivative of sine 3x, which is cos 3x times 3, and simplify. And then if I evaluate it, this tells me I should plug in 2 pi over 9 for x. I get negative 18 cos of 3 times 2 pi over 9. Okay, and I get negative 18 cos 2 pi over 3. Okay, which is what, now we want to prove that that equals 9. Remember that from our review on cosines and solving equations, cosine of 2 pi over 3, 2 pi over 3 takes us into quadrant 2. We can use our special triangles to evaluate this, that pi over 3, that the cosine of pi over 3 would be negative 1 over 2, and in this quadrant it's negative. Okay, so cos of 2 pi over 3 is negative 1/2, so therefore negative 18 times negative 1/2 gives us 9. Thank you, and continue along to our next video.